Hello, welcome once again to my channel, and today we are going to discuss the Wurtz reaction. You all know, you have studied in 11th class what is Wurtz reaction, what it is used for. So if we want to increase the number of carbons in an alkane, or if you want to make an alkane which is higher alkane, suppose we want to make butane from ethane. Ethane has 2 carbon atoms, whereas butane has 4 carbon atoms. So ethane can be converted into butane by using the Wurtz reaction. So how this happens, take the halogen derivative of this alkane which we are using, so CH3 CH2 Br, and 2 molecules of it reacting with sodium in presence of dry ether. So this sodium eliminates the 2 bromine atoms from the 2 molecules of this halogen derivative. So 2 NaBr is separated and you get butane. So friends, this is the Wurtz reaction. So I can convert ethane into, this is ethyl bromide. First I will make the halogen derivative, or ethyl bromide, or also known as bromoethane. So this is how you can convert this into butane. Now the question arises that it is mostly used for making the alkanes which have even number of carbon atoms. This is having 4 carbon atoms. If you take 2 molecules of this bromobutane and react them with sodium in presence of dry ether, then we will be getting the hydrocarbon that is having 8 carbon atoms. So the question arises that why do we prefer to make the hydrocarbon, or to use the Wurtz reaction for making the hydrocarbons which are having only the even number of carbon atoms? So the answer to this question is, suppose I want to make propane. I want to make propane from so how will I make propane? I will take bromomethane or methyl bromide plus 2 Na plus, it contains 1 carbon atom. So if I have to make butane, so I have to take bromopropane. So in presence of dry ether, minus 2 NaBr, this is eliminated, I will get butane or N-butane. So it seems that it can be easily done, but it is not so. The reason is that we are taking a mixture of 2 compounds. This is methyl bromide and this is bromopropane or bromate. Now what happens? The molecules of methyl bromide or bromomethane which are present, they will react with themselves, and there will be 3 types of reactions, and we will be, as a result of the reaction of these molecules with themselves, we will get ethane. In presence of dry ether, we will get ethane. Now what happens when the molecule of methyl bromide reacts with plus Br CH3 CH2 CH2 CH3. This is bromopropane or propyl bromide. So when these two react, we get butane in presence of dry ether plus 2 NaBr. Here we get ethane. Now, as I told you, there are three types of reactions. CH3Br react with themselves, then CH3 with propyl bromide, and propyl bromide react with itself. So what will happen when propyl bromide molecules react with themselves? In presence of dry ether, what we get is hexane. This is a hydrocarbon which contains 3 plus 3, that is 6 carbon atoms, so it is called hexane. So you can see the result. What happens? So we are getting a mixture of butane plus hexane plus ethane as a result of Wurtz reaction. So in this case, these three hydrocarbons are produced. So these hydrocarbons, they have different boiling points. As a result, it is very difficult to separate the mixture, or to separate the hydrocarbons from the mixture. It is very difficult. That's why the Wurtz reaction is used to prefer only for making the hydrocarbons which have even number of carbon atom, not for odd number of carbon atoms. This is a very important question, and very frequently this is asked in the exam, so you should remember this.